Alright, these are your notes for similar polygons. So this is the next thing we are going to do in this unit. So I'm going to go over these. This is the same thing we'll see in class as well. And just make sure you guys double check for homework assignments. That'll be posted as well. So when we do similar polygons, we use the symbol for similar. Looks just like congruent, but without the equal sign. So that is your symbol for similar. Remember, this symbol with the equal sign below it was the symbol for congruent. Now, what's the difference between congruent and similar? If shapes were congruent, it could be triangles, rectangles, whatever, 5-sided figure, 6-sided figure. If they were congruent, all their corresponding angles were congruent. They were exactly the same, and their sides were the same. If they are similar, the angles are still the same. So the angles are congruent. That doesn't change. The sides now become proportional. And the best way to explain this is if I were to just take a basic right triangle, like one that's got legs of 3 and 4 and a hypotenuse of 5, and then I put it in a copy machine and I enlarge it to make it twice as big. Well, when it comes out of the copier, it's still a right triangle, but now the one side that was 3 is now 6, the one side that was 4 is now 8, the hypotenuse that was 5 is now 10. So clearly the sides are not the same anymore, but they are proportional. The angles didn't change. That 90 degrees is still 90 degrees. Whatever this angle was here, exact same here. So the angles didn't change, but the sides became proportional. What proportion did we take to get from one to the other? Well, to get from 4 to 8, didn't we multiply by 2? To get from 5 to 10, we multiplied by 2. And to get from 3 to 6, we multiplied by 2. So we just made it 2 times bigger. Alright, so if they are similar, their angles match up. So what we're talking about here, looks like we have two pentagons that are similar. So angle A and angle J, they're congruent. If angle A is 110 degrees, so is angle J. B and K are exactly the same. There's your label right there. C and L, they are the same. D and M, they are congruent. And E and N are exactly the same. All you did was you took this original polygon and just shrunk it. Now, the sides are not the same, but they are proportional. Whatever AB is, it is proportional to JK. Maybe it's half the size, maybe it's a third of the size, but whatever, it's proportional. BC and KL are the same proportion. So maybe it's half the size, maybe a third, maybe a fourth, but it's the same proportion. CD and LM right here, same proportion. All you got to do is find the match. DE and NM, same. And the last one, EA and JN, still the same. Alright, so the sides become proportional, the angles don't change. Alright, all you need to know is the key right here. You'll have problems for homework, and all I'm going to do is give you the key. What this means is triangle FGH is similar, that's what that symbol there means, similar to triangle JKL. Alright, and again, if they are similar, the angles are the same. So it says list all pairs of congruent angles. Angle F is congruent to angle J. Angle G is congruent to angle K. And angle H is congruent to angle L. Remember, last one goes with last one. Middle one goes with middle one. Now, the sides are not congruent. They're proportional. You really don't even need to look at the two triangles. Just look at the key. That tells you everything. So FG should be proportional to JK. First two go with first two. GH goes with KL. So GH and KL have the same proportion. And then the last one, F and H, that's first and third, go with J and L. Okay? Alright, same thing. I'm not going to go through every single one of these. I don't even know what the shape is. Maybe it was a rectangle, maybe it was a trapezoid, whatever. But I know that they are similar. So again, if I were to call out in class angle N, it should be congruent to angle U. Angle R should be exactly the same as angle T. Angle P goes with angle V. Alright, and then sides. Side NP should be proportional to side UV. And I'm not going to go through all of them. Let's do side QR. QR should be directly proportional to ST. Q and R are the third and fourth. S and T are the third and fourth. Has to match up. Okay? Okay. Scale factor. It's exactly the same as what we're talking about with the ratios. Okay? So, the scale factor is just the ratio of the side lengths. So all I need to do is find a match here. So if this is shape A and this is shape B, the scale factor from A to B is simply 5 to 10. You can reduce that to 1/2. It's a 1 to 2 scale factor. Okay? And what if I chose this number and this number? Is 4 to 8 still the same as 1 to 2? Yes. Now be careful. What if I said the scale factor from B to A? Well, now you're going backwards. You're going from 10 to 5. So that is a 2 to 1. All right? And again, what if I did 8 to 4? Would that still be a 2 to 1 ratio? Yeah. So there's your scale factor right there. All right? All right, look at the next example. Determine the scale factor of triangle A to B. So we're going to go from A to B. So we would be 6 over 3. Well, a better way to do 6 over 3 is 2 over 1. Now, if you just said 2, that's okay. 2 over 1 is the same as 2. What if you did the scale factor from B to A? Well, then that would be different. That would be 3 to 6. That would be a 1 to 2 scale factor, a 1/2 scale factor. So be careful how they word it, which way you're going, B to A or A to B. Now, to tell if they're similar, they should have the same ratio. So, this piece here, this height, matches this piece here. The easiest way to tell if they match each other is to basically just change them to a decimal. Well, 6 divided by 10 is 0.6. If this is similar, this piece divided by this piece should be the same ratio. Problem is, 1 divided by 3 is 0.3 repeating. These two don't match. So are they similar? The answer is no. Alright, let's look at this one. Are they similar? It's just asking yes or no. Are they similar? All you got to do is find your match. Every proportion should have the same ratio. So if I choose 6, its match is 4. If I do 6 divided by 4, I should get 1.5. If I do 9 divided by 6, 9's match is 6. 9 divided by 6, take it on your calculator, is 1.5. 12 goes with 8. Again, easiest way to do this is on your calculator. 12 divided by 8 is also 1.5. So right now it's all looking pretty good. Last one we need to check is 15 and 10. Well, 15 divided by 10 is also 1.5. As long as they have the same ratio, they are always similar. So are they similar? The answer to this one, yes. Alright, now be careful on this one. Make sure you have a match every time. So I'm going to start with 12.5, and again, you might want to use your calculator since we have decimals here. 12.5's match, you went from the single mark to the double mark, should be 10. So we're going to do 12.5 divided by 10. So if we do 12.5 divided by 10, we get 1.25. If I don't get 1.25 for the other match or the other sides, I know they're not similar. Okay? So I'm going to do 11.5 and see who his match is. So I got 11.5. He goes from the double line to the nothing, so that would be 9.2. So I'm going to do 11.5 divided by 9.2. That's also 1.25. So right now it's looking pretty good. And then the last one to check is 15 and 12. So do 15 divided by 12. If you get 1.25, we're good, and we do. We get 1.25. So, are they similar? Yes. Remember, you got to have the same ratio for all sides. Let's look at this one. 10 divided by 18. You could do 18 divided by 10. It doesn't matter. Just make sure you keep them consistent. 10 divided by 18. 0.5 repeating. Alright, so if 10 over 18 should be the same as 4 over 9. If not, it's not a match. 4 divided by 9 is 0.4 repeating. We have a problem. They don't match. So are they similar? No. Just because they look similar doesn't mean they're similar. Alright? Now, why do we do all this? Because if they are similar, which is what it's telling you here, you can do proportions to find the value of x. Now, some of these are so simple you don't even have to do the proportion. It looks to me like they're telling you they're similar. So if they're telling you they're similar, you can go ahead and do proportions. 4 goes with 8, but what did it take to go from 4 to 8? Well, you multiplied by 2. Well, then you should just be able to multiply 3 by 2 and get 6. If these numbers aren't great numbers and they're decimals, make a proportion. So 4 goes with 8. As 3 goes with x. How do you do proportions? Cross multiply. 4 goes with x, that's 4x. 8 times 3 is 24. What's 24 divided by 4? X is equal to 6. Isn't that what we said it would be from the very beginning? Yes, so that one works. And again, if you can see it, don't do the proportion. If you can tell just by looking at it right away, just figure it out that way. If not, set up the proportion. The proportion will always work. Here you might have to set up the proportion because now you have some binomials. This is why we did those proportions earlier with binomials. So they're telling you they're similar. Now you got to solve for the missing variable. Let's solve for x first. In order to do these problems, find out who your match is. Y plus 3 and 8 is not a good match because I don't have definite numbers, so I don't want to do that. X minus 2 and 6 is a match, but it's not a good one to start with. Find your definite match. Your definite match is 21 and 14. So 21 goes with 14 as x minus 2 goes with 6. There's my match. And again, we did these the other day. This is why I did this earlier. You've got to do distributive property here. That's 14 times x minus 2 equals 21 times 6. All right? So 21 times 6 is 126. You got to do distributive property. That's 14x. 14 times a minus 2 is minus 28 equals 126. This is what the problems will look like on the quiz next week. So add 28 to both sides and you get 14x equals, so 126 plus 28, 154. And again, what's your last step? Divide by 14. X is equal to 11. So there's our one answer. But looks like I had two variables here. I also have y. Use the same proportion that worked. That one worked. So 21 over 14 equals, and again, if you put 21 on top, that was the big triangle. Make sure you use the big triangle on top of the next one. That's y plus 3. Who's y plus 3's match? 8. Okay, same thing. These two go together. That's distributive property. That's 14 times y plus 3 equals 21 times 8. That's 168. Alright, distribute. 14 times y, that's 14y. 14 times 3 is 42, so 14y plus 42 equals 168. Subtract 42 from both sides. Alright, you get 14y equals 168 minus 42 is 126. Divided by 14, y is equal to 9. Those are your two answers. X was 11, y was 9. These are the type of problems you'll see. Homework, quizzes, the next quiz, all the same. Okay? Alright, and again, look at this problem. I wouldn't try and figure it out. I would use my key. Alright? I don't even have to draw these shapes out as long as I have my key. That's fine. So first of all, I need to find myself a match here. Let's see. I see 12 here. That's A to F. That's the first and the last. So its match should be X and Z. I don't like that match because that's got a variable. So let's try this one here. C to D is 9. C to D should match up with WY. That's a good match. So I'm going to do 9 over 6 equals, let's solve for X first. X is F to D. Who was F to D's match? That's the last two. It should be YZ. Who is YZ? 10. That's an easy proportion. What's 6 times X? 6X. 9 times 10 is 90. Do 90 divided by 6. X is equal to 15. That was an easy one. And again, use the key. Now, to solve for Y, use the same match you already had. You know 9 goes with 6. 9 came from the big one. 6 came from the small one. So, who was Y's match over here? Remember, that was ZX. So that was the first and last. That should go with AF. That's 12. So it should be 12 over 3y minus 1. Again, you're going to have to use distributive property. So that's 9 times 3y minus 1 equals, what's 12 times 6? 72. 27y minus 9 equals 72. Add 9 to both sides. 72 plus 9 is 81. 27y equals 81. Divide 81 divided by 27. Y is equal to 3. All right. Okay. And we'll do this one in class, so I'm not really going to worry too much about that one. It's almost exactly the same as what you just did. Other topic that goes with this, if polygons are similar, their ratio of perimeters is the same as their side ratio. All right, it's the same as their scale factor. It's all the same. Okay, so what we're talking about here, the ratio of the sides is 4 to 8. So if this is A and this is B, to get from A to B, it's a 4 to 8 ratio. But doesn't that also mean a 1/2 ratio? That means their perimeters should also be the same 1 to 2 ratio. How do we know that? Well, if this side is 5, that side's 5. If this is 4, this is 4. So what's the perimeter of this rectangle A? 5 and 5 is 10. 4 and 4 is 8. That's 18. The perimeter of this one should be 2 times as big. 18 times 2 is 36. Let's see if that's true. If this side is 10, that side's 10. If this bottom piece is 8, the top piece is 8. 10 plus 10 is 20. 8 plus 8 is 16. 20 plus 16 is 36. So it checks out. So the ratio of the perimeters, which was 18 over 36, is the same as the ratio of the scale factor, which was 1 to 2, which is the same as the ratio of the sides, which was 4 to 8 or 5 to 10. They all should reduce to the same thing, which was 1/2. All right. So perimeter, scale factor, sides, all have the same ratio. Doesn't change. All right. And again, look at this one here. The rectangular patio around a pool is similar to the pool shown. Calculate the scale factor of the patio to the pool. So the patio is the bigger piece. It's 24 here. The pool's the smaller piece. So if we did the scale factor of patio to pool, it'd be 24 to 16. You can reduce that. 8 goes into 24 3 times. 8 goes into 16 2 times. It's a 3 to 2 ratio. Find the ratio of their perimeters. It should be exactly the same. 3 over 2. If you don't believe it, add them all up. So if you were to add the patio, it'd be 48 plus 48 plus 24 plus 24. That's 144. If you did the perimeter of the pool, that'd be 32 plus 32 plus 16 plus 16. that'd be 96. And again, remember, you can check this on your calculator, but if you did math fraction on your calculator, this would reduce to 3 over 2. So basically, you don't have to do all this work. The perimeter ratio is the same as the side ratio. All right. Now, when do you use it? Problems like this. This is what you'll see for homework. This is what you'll see on the quiz. Two similar rectangles have a scale factor of 2 to 3. So you got two rectangles, got a scale factor of 2 to 3. The smaller one must be the 2 because it's smaller, and the larger rectangle must have the 3 because it's more. So the perimeter of the large rectangle is 60. Find the perimeter of the small. So the question is, where do you put 60, top or bottom? Well, 60 was the large one. It says find the small. There it is right there. And again, cross multiply. 3 times x is 3x. 60 times 2 is 120. Divide by 3. 120 divided by 3. X is equal to 40. And there's your answer there. All right. Same thing. Two similar rectangles have a scale factor of 1 to 3. Okay. The perimeter of the small rectangle is 18. Find the perimeter of the large. Okay, so where do I put 18 since it's the small rectangle, top or bottom? It's got to go up top because 1 is less than 3. And there it is there. That one's easy. 1 times x is x equals 18 times 3, 54. All right, a lot of shortcuts on this. Don't have to do all the work. Okay. Let's go and look. I think we got 2 more, and then we're moving on, and that should be it. Yep, that's it. All right, I'm going to do the second to last one. I'm not going to go through everything here. Okay, so it's telling you that these two are similar to each other. There's your key right there. Find the scale factor of MNPQ to XYZW. So this is the first one, and this is the second one. We're going to find the scale factor from the first one to the second one. So all we got to do is find a match, and then we're done. So I have one number here, that's WX. So WX was the first and last one. So his match should be M and Q, first and last one. So M and Q is 8. So the scale factor from MNPQ, which was 8, to XYZW, which was 4, is simply a 2 to 1 ratio. That's it. Okay? All right, now it also said find the perimeter of each polygon. Well, we should be able to find the perimeter of this guy here. Just add them all up. 8 plus 7 is 15, plus 10, that's 25. 25 plus 9 is 34. So if his perimeter is 34 and it's a 2 to 1 ratio, the perimeter of this guy here has to be half of that. So it must be 17. Instead of trying to find each side individually, remember the perimeter ratio, the scale factor, and the side ratio are all the same. It's a 2 to 1 ratio. So the perimeter of this one has to be 17. You don't have to do all the work.